Okay, so welcome back, students. Now we are going to have a small lecture in continuation with what we have studied in the previous lecture in the number line. Because this part is in particularly specific to class 9th of ICSC as well as CBSC, and you will also find that this is a topic where children usually face problems in terms of plotting. So the topic as such is plotting an irrational number on the number line. So this number line, as we discussed last time, it is the real number line, because irrational numbers are also real numbers, just like natural numbers, whole numbers, rational numbers. Irrational numbers are also real numbers, so they all come under the category of real numbers. Okay, so let's see what we have to discuss today. Let's suppose that we have the real number line. So we draw a straight line with two arrows at both ends. Okay, and let's say we have a 0 here, we have 1 here, we have 2 here, then 3, and so on. Okay, and similarly on the left side we have -1, we have -2, and so on the left side as well. So you see, if you have to plot a number, let's say 2, okay, the number 2 has to be plotted. So this is number 2, you will plot it like this. Okay, suppose you have to plot a number 2.5. so 2.5 will be midway of 2 and 3, so somewhere here you will make a mark and you will write 2.5. okay, let me write this more clearly. So it will be 2.5 like this. Okay, similarly, if somebody wants to mark, let's say 2 by 5. Okay, 2 by 5 has to be marked, because 2 by 5 is what? That also belongs to, this is also a real number, so it belongs to the real number line. So 2 upon 5, when you will divide, you will have 0.4. So between 0 to 1 there are 10 divisions, so you will look for the fourth division, which is going to be your 0.4. okay, so just one mark before the midway between 0 and 1 will be 0.4. okay, so what I'm trying to tell you here is that whenever we take numbers like these, 2, 2.5, 1, -2, 2 by 5, -1 by 5, these numbers will be very easily plotted on the number line, because you can actually have, these numbers are actually numbers in which you can see that this is a whole number. Okay, this is a natural number, this is a whole number, quite clearly visible on the real number line. Similarly, a decimal number which is not too long, which is terminating at the first decimal place, is also relatively easy to plot. Similarly, suppose you have under root of 16, let's say, for example, you have to plot under root of 16 on this real number line. So under root of 16 is what? It is 4. We all know that 4 is the next whole number after 3. So this will be 4. So plotting such numbers will be quite easy on the number line. As such, it is quite easy. Why? Because you see, even though we have a root sign here, the number which is there in the under root symbol is a perfect square. Therefore, overall, if you see, this number is a rational number, as we discussed in the previous lecture. 4 is 4 upon 1, so it is in the P by Q form. So it is a rational number which is very easy to plot. So what is the problem that comes up, and in which case does it come up? So it is this irrational number which creates problems in terms of plotting. So we will see how to plot an irrational number, or a square root of a number which is not a perfect square. So let's say, for example, we have now I'll erase this portion. So okay, so here is the setup. You see, the question is plot root of 5, which is square root of 5, on the real number line. Okay, now the number which is present in the under root sign is not a perfect square. okay, because 5 is not a perfect square. So naturally, by the definition when we discussed in the previous lecture, this will become an irrational number. Okay, now when you actually find out the root of 5, just like we calculated root of 25, it came out to be exact 5. But this will not give you an exact number. Okay, it will go in decimal first of all, and then that decimal will also not be quite easy, and it will not terminate easily. Okay, so that number will go on like 2 point something. Naturally, you can have a look at this root 5 and you will come to know that it is going to be 2 point something, because 2 squares is 4 and 3 square becomes 9. So it has to be between 2 and 3, more on the side of 2. Okay, so 2 point something. Now what is that something? We don't know yet. Okay, and it is precisely because of that we cannot plot it on the number line precisely. Okay, so there is a particular way of solving such questions, of plotting such numbers which are actually belonging to the category of irrational numbers. So what is that idea? That is what I'm going to give you now. So you see, we will use this calculation. We have let's say we have a right angle triangle. Okay, so we have a right angle triangle like this. Okay, suppose the base is 2 and the perpendicular is 1. Okay, in terms of units, let's say 2 centimeters and 1 centimeters, or 2 units and 1 units. Okay, so by Pythagoras theorem we all know that this hypotenuse can be calculated as root of this square plus this square. So hypotenuse, this h can be calculated like under root 2 square plus 1 square. Okay, so which is going to give you 2 squares is 4 and 1 square is 1. So you are going to get under root 5, which is, if you remember, the number which we have to plot on the number line. Okay, so in such cases what we are going to do is that we are going to express this number in terms of squares of any two such numbers. So that is something that you will have to practice, because 5 we all know we can obtain 5 by adding 4 and 1, and 4 is a perfect square, 1 is also a perfect square. Okay, so the reason why I am showing you this right angled triangle is because if we have root 5 as the hypotenuse, okay, let me select a, so if you have root of 5 as the hypotenuse, then the respective base and the perpendicular will be 2 and 1. Okay, because just now I showed you this is going to be, hypotenuse is going to be root 5 if the base and the perpendiculars are 2 and 1 respectively. Now the big question comes is, why are we using this particular Pythagoras theorem? Why are we drawing the right angle triangle to do this? So the reason here is that you cannot really directly plot root 5, because although you know root 5 is lying between 2 and 3, closer to the 2 side, but then the exact number cannot be known as of now. Okay, so what we are going to do here is, we are going to, from 0 we are going to take this base distance of 2 units, because in my right angle triangle, this triangle, you can see that the base is 2 units. So from 0 you will move up to 2. So assuming that this is the base. Okay, so how will the perpendicular go? The perpendicular will go up like this. So let me just draw that vertical line to show you how it will go up. So let's say, for example, goes like this. Okay, so this is going to be that 90-degree angle. And how much do you have to go up? You can again look at the right angle triangle. The base, this base was 2, so I selected the base as 2. Now what is the perpendicular? The perpendicular is 1. So from this point you will go up. So you can imagine that let me just draw the y-axis also, so that you don't get confused. So assuming that this is my y-axis. Okay, so this is my x-axis, this is your origin, this is negative x, this is plus y. So you see, how much will you go up? You will go up by 1 point. So let's say this is that point 1 which is going to be there, because naturally this is going to be, when you go up above the origin, you have 1 2 3, just like you are having 1 2 3 on the x-axis, you have 1 2 3 on the y-axis also. Okay, so let me mark this 2 also, although this 2 will not be required, because how much do you have to go up? Look at the triangle, you have to go up by only 1, so you have gone up by 1. So essentially what has happened is, you have gone along the base by 2 units, you have gone up the perpendicular by 1 unit. So don't you think that if I join this point with this point, it will give me my hypotenuse? Yes. So let me just join this like this. So if I consider this to be my right angle triangle, naturally this becomes the base, this becomes the perpendicular. So this is like 2 units and this is 1 unit. So therefore my hypotenuse becomes root 5 units. Now I had to plot root 5, but not here. I have to plot root 5 on this number line. So now after having this applied this concept, what you can do is, you can see the part that is left is, this length is root 5, but the only problem is that you don't have to plot root 5 at this point. This has to come down on this axis, because this is your real number line. Okay, so the same distance has to be copied here. So how can you do that? By selecting a circle having a center at this origin and this much radius, so that when it moves around like this in a circular kind of a fashion, it is bound to cut the axis here at some point, and that point also will be at root 5 distance from the origin. Why? Because this is the center of the circle, so all the radii will be same all across. Okay, so I hope you have understood what I am trying to tell you here. This is the origin, this is your radius, so you can call this as r is equal to root 5, but you cannot plot the point here because your real number line is here. So this equal distance has to be copied. So how can you copy that? By taking this to be the radius of a circle, because when the circle, the locus of the path of the circle moves, then the radius remains the same. So with the help of a compass and a pencil, you will put your compass needle here, you will put the pencil here, measure this much, not exactly measure but adjust it according to this length, and then you will draw that circle. So when you draw that circle, it will come like this. Okay, so when you draw the circle will go like this. You can if you want, you can complete the circle will go and look like something like this, but then the point that you are concerned with is this point. Okay, it is this point which you will write as root 5, because if this is the center of the circle and this was the radius, so then this is also that same radius. Okay, so if this was root 5, this much will also be root 5, because these are both the radii of the same circle. So you can see again for confirmation, we knew that root of 5 will lie somewhere between 2 and 3 and it will be closer to 2, and this is exactly what you see. So from this point to this point, this is your root 5 distance. Okay, so this is that plotting. Remember, we had to do that plotting of root 5, so this point is root 5. Okay, so this was an easier example to take. I'll give you an example which you can try on your own also. So let's think of a number. Suppose somebody wants to plot, let's say, so what number shall we take? Let's say, okay, let's say 49. No, 49, 7 sevens are 49, it will be exact. So okay, suppose you have root 20, let's say, for example. If you have root of 20 to be plotted on the real number line, so is 20 an exact square? No, 20 is not an exact square. So even if you find out the prime factors, so it will be 2 into 2 into 5. So although 2 can be paired, 2 can come out, it will still remain 2 root 5. Yes, so you can have, this is an irrational number, so you can have plotting of root 20. So suppose you have this as the question. Plot root 20 on the number line. Okay, so on the number line. Which number line? The real number line. Okay, so how will you do this? So again, the process will be same. The breaking up of root 20 has to be broken up. So you can see, if you want to make a triangle, let's say for example, root 20 has to be the hypotenuse. Okay, so if 20 has to be broken, you can have, let's say, okay, so 20 is like 16 plus 4, right? 16 plus 4, so 20 will be 4 square and 2 square. Yes, I think we can break it up like this. Root of 20 will be root of 16 plus 4. So you can have root of 20 as root of 4 square plus 2 square. So essentially what that means is that your base will be 4 units, your perpendicular will be 2 units. Okay, so that 4 square becomes 16, 2 square becomes 4, 16 plus 4 becomes 20. So your hypotenuse becomes root 20. So it is this that you have to plot. So you cannot naturally plot root 20 directly on the number line. So once again, you will have to, let me show you this. You will have to draw a number line like this. You will have to mark a 0. Then you will have to mark, let's say, 1, 2, 3, 4 and 5, let's say. So from 0, how much will you go along the base? 4. So you will come here and then you will draw a vertical line like this. How much will you go up from here? You will go up by 2 points. So mark that 2 and then join this from here. So this part will become root 20. Okay, so then with the help of a compass, you can draw this. So that point will come somewhere here. Okay, because naturally root 20 will come between 4 and 5, because 4 square is 16, which is lesser than 20. 5 square becomes 25, which becomes greater than 20. So naturally root 20 will come between 4 and 5. So always use this right angle triangle concept to break down this number into squares of two numbers which you can plot. Okay, and then you can use that compass method of drawing the circle. I hope you will get some help from this lecture, because usually the plotting part is where children usually get confused, and it is rather difficult to understand also. Yes, you can use the graph paper to draw this, but then you will certainly have to use the compass for that. Thank you.